Welcome to section 2 of this course, exporting AutoCAD objects to Excel. The first object that we are going to export are the line objects. So we will be exporting the starting point and end points, both the X and Y coordinates. We're going to export also the layer, line type, and the length. Next, we will be exporting the M text, where we're going to export the insertion point, both the X and Y coordinates, the layer, the width, the height, the style, and the text string itself. And then followed by the polylines or the lightweight polylines, where we're going to export the layer, the line type, the length, and the vertices, all of the X and Y coordinates of the vertices. Then it will be followed by exporting the blocks that doesn't have any attributes. So we will be exporting the block name, the insertion point, rotation, and probably a few more properties. Then that will be followed by the blocks with attributes. So in this particular case here, we are going to export one block at a time, which means that we will provide the user with a user interface to select what block they would like to export, because they have their own sets of attributes, so we cannot combine them into one spreadsheet. Okay, so in the next video, we're going to start working on exporting the lines. We're going to create our project or plugin. I'll see you there. Just before we jump into the code, let's just have a very high-level understanding of the objective. So we have here our AutoCAD drawing, and the intention is to extract the line objects from the drawing into Excel file. So this is just my sample drawing, but you can use any drawing you want. So these will be the columns that we're going to extract. We have here the start point X and Y coordinates. We have the endpoint, also the X and Y coordinates, and we have the layer, the line type, and the length. So once we run the plugin, when we're done coding with this, this is the Excel spreadsheet file that will be created. And now let's just jump into the high-level flow chart. So the first thing that we should do is to select all the line objects from AutoCAD. Then just do a very quick validation if there is a line selected. If there is no line, then display a message and then exit the program. That's it. Otherwise, if we have some lines, then we'll have to loop through the selection set. And then for every single line, we're going to do the extraction process. And they will go to the spreadsheet with all these properties here that we're going to extract. These are all these columns that's being represented here. And then just go through the loop. For every iteration, check if there are still some line to process. Then it will go repeatedly until it finished all the lines in the selection set. And then we end the program. That's it. So in the next video, we're going to start our coding. I'll see you there. Okay, so now we are ready to create our project. Fire up your Visual Studio 2019 and click on Create New Project and choose Visual Basic. Then search for class library. And we are going to use this .NET Framework class library. Specify your project file location. In my case, I put it in this projects vb.net folder. And let us just simply call this project as vbnet-excel and .NET Framework 4.7.2 here. Click on create. Okay, so first things first, we need to have a reference on those .NET APIs, the AutoCAD .NET APIs. So click on references and click on add reference and browse. So in my case, my AutoCAD installation is on program files, Autodesk AutoCAD 2021. So we need those AC Core MGD, ACDB MGD, and the last one is ACMGD, this one here. Click on add and OK. And next we have to set this copy local to false, so that when we compile it, we don't add all of these DLL files into our bin folder. Next, we need to add the Excel object, Microsoft Excel interrupt object. So click on add reference again and select on assemblies. Here we will select the Microsoft where's that Microsoft Excel? No, it's in the COM. Microsoft. This one here. Microsoft Excel 16.0 Object Library. Okay, so now we have here the Microsoft Office interrupt.excel and the three .NET APIs. Okay, so the next thing that we should do is to import all of those namespaces or all the libraries, the AutoCAD.NET libraries. So imports autodesk.autocad.application services. Another one is database services. The next one is runtime, autodesk.autocad.runtime, and also the editor input. And finally, we need to also import the Excel. So imports. In here, we are going to make the Excel as an alias for Microsoft.office.interrupt.excel. There you go. So this is our project. We just rename this class1.vb. Let's just rename this to let me call this as export Excel util. And click on yes so that it will rename all of the references. Okay, so now we have the project structure. Okay, now that we have a good understanding of our first program requirement, which is to export lines from AutoCAD into Excel spreadsheet, let's get going with our project here. So the first thing that we can do, although there is no hard rule to where to start, you can start creating the user interface or the UI, or you can start creating the method. So in our case, let's just start with the user interface. So from your project, right click and click on Add and select the Windows Forms here. Let's just rename this as Excel Util Form. Click on Add, and now we have our form. So let's just do some property changes here. So the start position, we'll leave it as a Windows default location. For the text here, let's just Excel change it to utility form. Okay, and just a few more properties here. We will change the maximize box to false. This is the one here, so that the user cannot maximize this. Otherwise, it will just cover the entire AutoCAD window. And that's it actually for the form. So we have our name here, which is Excel Util Form. And now we can add some controls. So based on the user interface that I have shown you from the previous PowerPoint slides, we will have different group containers for each of the functions. So in our case, we will start with exporting to Excel functions. So click on the group box here from the containers category. And let's just change this group box name into, the text to export to Excel functions. This will be the container for the buttons to do the exporting into Excel. And now we can add a button here. Let's just change. The text will be export lines, and the name of our button, let's just call that as BTN export lines. And let's change some appearance. Let's say the background color to navy and the fore color to white. Okay, and the font, let's just change the bold to true. And that's it. So if we now double click on this, it will create for us a method here, a sub method. We'll do our coding later on for this one because we haven't created the method from our export Excel util class yet, but at least now we have this button um, stub. So going back to the form, we need to provide some messaging to the user. For every single process, at least we will inform the user what happened during the execution. Did it run successfully or did it fail? So let's provide here some messaging. Let's call this as LBL info. Again, when you are interacting with the controls from your form, it's always good to provide a descriptive name so that it will be easier for you to recognize what particular control you are dealing with. So we have here the name LBL info, and you can just change this initially to whatever text you want. In this case, just 3 dots. So now we have our Excel utility form. And if we go back now to our export Excel util, now we can create the plugin command, which means that from the AutoCAD command line interface, the user can just type in our plugin name. So in our case, let's create a sub method. Let's just call that as show Excel util form. Okay, and all this method will do is to display the form so that the user can interact on the form. So we just need to create an instance of the form. So dimension form as new Excel util form. Okay, and then we can just show the form to the user or display the form. So we have a method. However, AutoCAD will not recognize this until we put the command method. So you put that there, command method, and specify the command name. So you can put here any name you want. But in our case, let's just use the same command method here. And that's it. So the user can type in this command from the AutoCAD command window, and then the form will display. So if we do a build, okay, it built successfully. However, there is a warning here that saying there's a mismatch between the processor architecture of the project and the processor architecture of the reference .NET API. So what it says is to consider changing the targeted processor architecture in the configuration manager. So we can do that from here. Click on configuration manager and click on the active solution platform, create new, and leave it as x64 and OK, and close. So if we do another build or do a rebuild, the warning is gone. All right, so now we can try running this plugin. Let me just do another configuration change here to start the external programs. So you might have a different path for your aka.exe file. So put it there by browsing it, and then you should be good to go. So if we start on debugging, just to see that our plugin working, our plugin is working, even though there's no built-in functionality yet, at least it should show us the form. So let's give it a go. Let's see how it goes. Let's just select one of these drawing here. Okay, so now we have our AutoCAD open. Let's type in net load to load the plugin. And let's search for the plugin there. We have here the BVNet Excel. It's from the projects, by the way. BVNet Excel. And go to the bin folder. Select on x64 debug, and then select the DLL file and click on always load. There you go. So now we should have a command called show Excel util form. All right, this is the one we just created, and there it is. We now have our form. If we click on this button here, it does nothing because we haven't provided any code functionality yet. But at least now we can see our form. So in the next video, we're going to work on the method to extract the line objects. I'll see you there. Now that we have our user interface ready, we can start building the method. So let us create a new method. And this method will be a function instead of a sub, because function returns a result to the calling program. So in this case, public function, let's call this as export lines. And we are going to return a string, okay? Which means whatever the result of our export process, we have to provide a message to the calling program in the UI to display it in the UI. So let us create a variable here called result as a string. And let's just initialize this as an empty string. And at the bottom, we have to return the result. This will be our function skeleton program. So now there are two major things that we need to prepare in this method. The first one is to gather all the lines in a selection set. So basically we will store all the line objects from AutoCAD into a selection set. And the other one is to, once we have that data, we can connect to Excel and extract the information. And all those information will be provided in a worksheet, in the Excel worksheet. So connect to Excel and get a worksheet. Okay, so these are the two major kind of sub module or sub method that we need to create. We can do it here to connect to Excel, but since we are going to extract different objects, like we have to do another extraction method for mtext, for polylines, so we might as well create a separate function that will provide us the spreadsheet or the worksheet that we need. So in this case, we need to create a new function. So basically, it will give us the worksheet that we need. So let me call that as private function. The reason why it's private, because it will just be used from within this class. It will not be used from outside of this class. So it's just a private function. Let's call that as get Excel worksheet and worksheet. And we are going to return a Excel dot worksheet. Okay. So we can now create a instance of an Excel application. So let's just create a variable called Excel as Excel.application. Next, create an Excel application object and make it visible. So Excel equals create object, and then it should be an Excel.application. Next, we have to make it visible, equals true, so that every time we are writing to an Excel file, the user can see what's happening on the Excel worksheet. The next one is to create a new workbook. So dim workbook or WB as Excel.workbook. And now WB equals Excel.workbook or workbooks rather that add. And the last one is to create a new worksheet. Now that we have a workbook, now we can create a new worksheet inside that workbook. Okay, so dim worksheet or WS as Excel dot oops, worksheet. Okay, and then WS will now be workbook dot worksheets, and then we are just going to have one single worksheet in that workbook. and we have to just return the worksheet. And that's it for our get Excel worksheet method. So we have created an Excel application. We created a workbook, and then we added or we created one worksheet, one single worksheet in the workbook. And then we return the worksheet here. So now, in order for our export line function to have an instance of the worksheet, all we have to do is declare a worksheet variable as new excel.worksheet worksheet, yeah, and now that will be equal to get Excel worksheet. So whatever returned from this method here, we can store it in our WS variable, and then we can just rename the worksheet as, say, lines. And that's it for our worksheet connection or Excel connection. And another thing that we need to do here is to gather all the lines in a selection set from AutoCAD into a selection set. So again, same concept as the get Excel worksheet function. We will be needing the method to give us whatever object type that we need. So in this case, instead of us creating the method from this, I mean creating the selection of objects from within our method here, we might as well create a separate method in a separate class so that other modules that we will be developing in the future can use that rather than us having a duplicated code from each of the method here. So in this case, I will create a new class and we will call that as a common util or a common utility. So right click on the project, add and select class. And let's just call this as common util. Okay, so the method that we are going to develop from this common util class will be common to the entire project. So instead of us writing each of these code from every single method, we just write it once and then we can just pass on the parameters and we will receive the results that we need in a selection set. So now let us build this common util. First off, we need to import all those AutoCAD.NET API. So by we can just copy over from here actually. This one here. So we will be needing all of it. We don't need the Excel because it doesn't have any functionality that relates to Excel. All we need is these .NET assemblies here. Oops. Control C and Control V. Okay. We need to add one more, the geometry, autodesk.autocad.geometry. The runtime we don't need because there is no functionality there that we will be using. So only these four namespaces we will be needing. So in this class, we can create a method called getObjects. So basically, get all the specified object. For example, line, mtext, and so on, and returns a selection set. So let's call our method as public function get objects. And in here, we are going to specify one parameter, which is the object type. and we just have this as a string data type, and the return will be selection set. Okay, so that will be our method. So in order for us to collect or to gather all the objects, all the specific objects from within the drawing, from within the model space drawing, we need to have a handle of the document object. So dim doc as document, which is equal to application dot document manager dot mdi active document. Then we also need to have a handle of the editor input object. So dim edt as editor equals document dot editor. So this is where we can create the filter and the type value. So let's create a type value. Let's call that as TV as type value, and that will be equal to new type value, and we have 1, which means we have 2 items in our filter array. And let's initialize it to a blank array. Now we can specify the filter criteria. So type value that set value, that would be a new type value, and we need the DXF code start, so we'll have to cast it into an integer. So we have here the cint method, and DXF code that start, that would be the obj type. So basically this is the first criteria in our type value variable. The next one is tv.set value, new type value. Now we only need to select the objects from the model space. So we have to provide 67, which is the DXF code of the model space in AutoCAD. And 0 means model space, and that is the second value in our type value array. Okay, so just a note here, this is only select from model space. This is the default. If you want to select from paper space, you have to specify here 1. Okay, so in this case, it's just 0. Next, we can create now a filter, a selection set filter. So let us create or define a variable called filter as selection filter equals new selection filter, and we pass on the type value. Next, we have to create a prompt selection result object to select all the objects specified from our type value here. So dim PSR for the prompt selection result as prompt selection result equals, that will be coming from the editor object. So edt dot select all, and we pass on the filter. So this method here from the editor object will select all the object based on this filter that we specified, which means that whatever is the passed on value here, if it's a line, if it's an mtext, if it's an LW polyline or a block, it will be filtered out by using this method call here. And next, we have to create a selection set. So dim SS as selection set, that would be equal to the prompt selection result here, the PSR dot value. If there is a value that's been selected or gathered, then we will have our selection set object here with those values. And all we need to do now is to return the selection set, as this is our return value here. And that's it for our common util method, which means now that all we need to do is create an instance of the common util class, then we can call this method already. Okay, let us save this and we go back to our Excel util, our export Excel util. So now we can create a, or we can instantiate the common util object, and then we can call that method. So in this case here, we have to create an instance of the common util. So dim common util, let's just make it cu as common util equals new common util. Okay, and now we can call that method the get object. So we have to declare a selection set variable. So dim ss, that would be equal to cu, the common util that get objects. See this one here? This is the one that we created. And we are going to pass on a parameter value. In this case, we're going to pass the line object. So this line will serve as the first filter value here. It's the object type, which is a line object. Okay, next we can validate if ss is nothing, then all we have to do is return a message saying that no line found in the drawing. At least the user will know that, oh, there's no line there. So that's it. We don't have to continue executing the rest of the code here because there's no point. We don't have any line to process anyways. So all we have to do is return the message and that's it. So now we have these two created. We have gathered all the line objects, and now we have also the worksheet created. So in the next video, we're going to create, we will complete the export lines method. I'll see you there. All right, let's finish up now our export lines method. So now we have gathered all the lines. We have the spreadsheet worksheet created for us. So let us now do the actual extraction of the properties. Let me create a try-catch block here. In this way, we can capture whatever error that we might encounter when running the code. So inside this try-catch block, we'll have to move this one in the try-catch so that all of this code, including the ones that we'll be writing, will be inside the try-catch block. So any error will be handled properly here. So in this case, if there is an exception, we will just store the error message in a result variable. Let's say error encountered. And then let's just attach the message, whatever the error message is. And then we return it to the user also, or to the calling program. Okay, so that is handled. Next, so now we can start creating the header of the spreadsheet file. So create column headers. Before we can create a header, we need to have a range object, the Excel range object. So dim, let's just create a range as Excel.range object. And from within this range variable, we can now create our header. Let's say from the worksheet that range, and we can just simply provide here the column and row location or the cell location. So this is okay since we know what are the columns, what are the column names, and where they are located. So it's fine for us to hard code the actual the cell location. But in the future methods that we will develop, we will be interacting with cells where we can dynamically uh, put the exact location of the cell data. So in this case, since we know exactly what we need to put, then we can use the hard-coded value. That's fine. So in this case, now we have range that value equals, this will be the start point x coordinate. So let's just call it like that. And then we can just copy this over multiple times. Let's just end there in the meantime. So the next one will be the B1. So in this case, if we have an Excel here, this will be the A1, which means that this is the start point X. And now we have here the B1. This will be the start point Y. This one here. So start point Y, something like that, and so on. So next we will have the C1. This will now be the endpoint X, and the B1, which will be the endpoint Y coordinate. And next we will have to add the layer, the line type, and the length. So this will be the E1, and this will have a layer header. Will be the F1 with the line type header. And finally, we have the G1, which is the length header. And that's it for the headers. Next, now we have to loop through the line selection set and extract to Excel one at a time. So this is now the main function from within the flowchart that we have discussed earlier. So in this case, we need to have a document object again. So dim doc as document equals application the document manager that MDI active document. And now we should have a row number handle, which means that we need to increment every single iteration. We have to increment the row number so that we keep on adding one row at a time here. Okay, so in this case, we'll create a variable called row num as integer, and we can start from number 2. This is the second row. Okay, we have the header as the first row, and all the information, all the data that we will be extracting will start from row number 2. So next we need to have a transaction so that we can loop through the line properties. So using trans, we'll create this trans as a variable as a transaction equals document that transaction manager that start transaction. Okay, next we have to loop through the selection set. So for each let's just call this as string object as or a selected object, a selected object in selection set, which is SS, that came from our selection set here. So we need to cast the entity from the selection set into a line object. So dim line as line equal to, so since we are casting it, we need to provide a try-cast method, and that will be the trans.get object, that is the selected object here, sobj dot object id, then open mode dot for read, since we are just reading the properties, and then that should be cast into a line object. Okay, so now we have a line object. All we need to do now is extract the properties that we need and make sure that they are properly put in a correct uh, range location in our Excel file. So a worksheet that range, and we can just concatenate the, let's say this is my first column, A column, and the row number, row num, that value is equal to line that start point that x coordinate. So this is the first range, which means that A and the row num starts at 2. So A2, we will put here the x starting point. Okay. And then we just have to copy this. And let's say, let's just copy it to 4 lines first. So the next one will be B. So this is again B2 because we are not incrementing it yet. And this will be the y coordinate. Next, this will be the C2, and then this will be the endpoint. Line that endpoint that x coordinate, and then this one will be the line that endpoint that y coordinate. And next, we need the layer, the line type, and the length. So this will be D, and this will be the E, range E2, and this will be line dot layer, and this will be F2, line dot line type, and finally this will be the G2, which is the length of the line. Okay, and that's it. So before we go for the next iteration, we have to make sure that we increment the value of row num. So row num plus equals 1, which means that now the next iteration, our row num becomes 3. So it will now go into this next row, and so on and so forth. So every row we have to extract all this information and then write it into Excel file. And then when we are done, all we have to do now is provide a message to the calling program. Let's say successfully extracted lines to Excel. And then here at the bottom, we return the result. So that's it for the export lines method. In the next video, we're going to try running our first method and see if we extracted all the lines from AutoCAD into Excel spreadsheet. I'll see you there. Okay, so we are done with the export lines method. We can now test our code. Just before we test the code, let me just do some update here. This is supposed to be endpoint Y. All right, there you go. So let's go back to our user interface. Now we can provide a code behind this button click event. Okay, so if we double click again, this is our method that's been created for us earlier. So all we need to do now is create an instance of the export Excel util object where we can execute the export lines method. So let's do that. Let me create a new variable. Let me just call that as Excel util as new export Excel util. Next, let's create another variable. Let's say result equals. Now we can call this Excel util instance, and we have here the export lines method. Okay, there you go. And of course, since we have a result here and we need to display to the user, all we have to do now is call our LBL info label control and specify here the text, which is the result. And that's it. So let us save our project and do a rebuild. Yep, one succeeded. So let's debug our program. Okay, let me open up one of the drawing here. So in this drawing, there are quite a number of lines. Let's filter out using the AutoLisp command or AutoLisp program. Let's say set queue lines. We use the ss get 0 dot line. That is, this will be our filter criteria. Now we have here selection set 4. So let us see how many lines do we have. List, and then specify the lines variable. We have 76. Okay, so we have here this. These are lines, the stairs, and also the cyan color one. These are the deck. Okay, these are line, and also this one here. This is the layer deck also, and another one is this layer stairs. These are line also. Okay, so we have quite a few lines here. So next we have to use the netload command again to load our program. This is the one that we have just compiled. Okay, so let me just just resize this, and all we have to type now is the show util form. Show Excel util form. Okay, there you go. So once I click this, it should open up Excel because we set it to visible equals true. Then it will populate one record at a time based on the lines that we have uh, selected. So let me click on this one now. There you go. And that's it. So we have here the header, start X and Y, end X and Y, layer, line type, and length. And we have here 76 records, 77 minus the header, of course, so it will be 76. And these are all the coordinates. Okay, and our method works as expected. And also you can see here the message successfully extracted lines to Excel. Perfect. And that's it for our first program. So in the next video, we will work on mText. Okay. And by the way, let me just also point out, this is the worksheet name that we have created here. We have the lines worksheet. So everything in our code works as expected. And we can move on to the next program. I'll see you in the next video.